Welcome. Today we're going to learn how to solve a quadratic equation. Specifically, we want to learn how to determine how many solutions that quadratic equation has. Now, a quadratic equation can have no solutions, one solution, or two solutions, and let's figure out how to determine. So right now we're going to be specifically talking about y equals ax squared plus c type of equations. There's no bx in these equations. These ones are fairly easy to graph, and the technique I'm going to show in this video is how to graph these equations out to determine the number of solutions that it would have. So let's first start by talking about what we know about a equation written in ax squared plus c form and one written in ax squared minus c form. So there's a big difference there, and it's just the operation that we're doing with the c value. Are we adding the c term, or are we subtracting the constant? Now, when we're adding the c like we are here, we're going to be moving our parent function up off of the origin of 0, 0. So that could be shifted up, and our parabola would be above the x-axis. Now here where I have negative c, I'm going to be shifting downward, and that would be starting off, and my vertex would be below the x-axis. So here we're above the x-axis, here we are below the x-axis due to adding or subtracting the constant at the end of the equation. Now that we know that, let's take a peek at what we're looking at in this lesson. We have three different equations written out here. X squared minus 1 equals 0, x squared equals 0, and x squared plus 1 equals 0. Notice each one of the equations is written equal to 0 because when solving a quadratic equation, you're trying to find the zeros. And what I mean by that is where the parabola crosses the x-axis, meaning the y value would be at 0. Okay, so we're looking where it crosses on this horizontal axis we know as the x-axis. Here we have the y-axis on each one of these. Now, if I were to graph each one of these, you're going to notice all three of them are very different. First off, x squared minus 1. Because it says minus 1, we're shifting down off the origin of 0, 0. So down 1, here at negative 1, we're going to have our vertex, and then we're going to have our parabola rise up from there. Our two solutions to this are going to be right here and right here. These 2 points where it crosses the x-axis, those are our solutions. So this example has 2 solutions. And those and those solutions would be each of these points. There's one at 1, 0 and one at negative 1, 0. So these two values are solutions to this quadratic. Now we go to x squared equals 0, which is just a parent function. Everything is based off of the parent function of x squared. Parent function goes through 0, 0, and we get a parabola that looks like this. Notice that this one doesn't cross, but it does hit and intersect at this point right there. So we are only hitting the x-axis at one point, therefore this has one solution. And that solution is 0, 0. Now our final example here is x squared plus 1. This one says plus 1, and because it's an ax squared plus c type of equation, we know that we're just shifting up 1 unit. So we're going to have a parabola that rises up, starts at 1 with our vertex, so it's just a shift of the middle quadratic that you see, the parent function. We shifted it up 1 unit, and it's going to look like this. Now what you notice about this parabola is it does not ever hit the x-axis. Never does it cross right here on this x-axis. Therefore, this would have no solution. There's no possible way to put a value in here and then end up getting a 0 as a final result. No solution. And the reason for that is if we're going to add 1 to make 0, we'd have to have a negative value here. There's no way to square something and get a negative value. Because if you multiply negative 2 times negative 2, You square -2, you're going to end up with a positive. If you multiply a positive by itself, it's obviously going to end up as a positive. Okay, let's go to 2 more examples, but before we move from this, real quick, take one more peek at this screen. We have let me circle with a different color. We have 2 solutions because it crosses that x-axis twice. We have 1 solution because it hits that x-axis once. And we have no solutions because it's never hitting this x-axis. That's all we're doing here. If we're just asked to determine how many solutions the quadratic has, just graph it real quick and find out how many times it hits the x-axis. Okay, our last 2 examples here. X squared minus 16. It says minus 16, so I'm going to be shifting my parent function downward 16 units. So I'd be down here at -16. I'd have my vertex, and because nothing else has changed on the equation, it's just going to be a normal parabola, parent function type of parabola, rising up. We know that if it's rising up, it's going to hit here and here at some point. That would be a 2 solution quadratic. So this one has 2 solutions. I was able to determine that pretty quickly just by knowing what the graph's going to look like. Now, you don't need to take your time to make perfect graphs here if you're just being asked to determine how many solutions. You could just give a quick sketch of what the graph's going to look like, because if the vertex is below the x-axis and you're rising, you're obviously going to hit once and twice. Okay, for this next one, we have 2 parts to look at. We have the 3x squared. That's just telling me that it's going to be a very steep parabola. It's going to rise much quicker than an x squared over here. So 3x squared means we're just rising much faster. And then the plus 6 here tells me we're starting, our vertex is shifted up 6 units. So I'm going to go up here to +6, put my vertex. And remember, this 3x tells me that we're just rising faster. So my sketch of this graph is going to look more like this. Notice that that parabola is much steeper, rising at a greater rate than this previous one. And this here is not crossing the x-axis anywhere. Therefore, this would have no solutions. Okay, in future videos, I'll teach how to find exactly what those solutions are, given this point, given that point, and know the exact amounts or values that those are. But for right now, just determining if it has none, 1, or 2 solutions, you just need to make quick sketches to determine that on your graphs. Hopefully this helps. Study hard and good luck with your upcoming